So now we're ready to start shaping the leading edge. And you'll recall that I had initially tapered the leading edge before I installed it to match the initial contour of the rib. So now all I have to do is put the final radius on it. So we'll start out with a few strokes of the razor plane. And then finish up with the sanding block. Now you can use a template at this point to get a precise shape on the leading edge if you like. I typically don't do that when I'm working with small leading edge. If the leading edge were, let's say, a 1/2 inch thick and 3/4 inch high, then I might use a template in order to get the airfoil shape properly. Since we've got the tip joined on to the main panel at this point, you have to be careful when sanding on this particular section right here so that you don't cut into the finished sanded leading edge of the tip. I always try to use the block on the long dimension. That way it helps prevent getting scallops in the leading edge while you're sanding. And you can listen for a sound. You can hear the sound that the sanding block makes when it's touching the ribs as you're sanding. So when it gives you that sort of sharp, scratchy sound, that tells you don't rock the block to that side anymore, but keep it level. All right, we've now finished shaping the top of the leading edge and are ready to clean off the bottom of the protruding material. Just take a coarse sandpaper. I guess I might mention that I typically use 100 grit sandpaper for everything except for the absolute final finishing. I've found that 100 grit, if you press hard on it, it'll cut fast. If you press light, it'll give you a fairly smooth surface. So that's what I use. And this is a new piece on a small T-bar, and we'll start sanding it off. There's one little trick I wanted to point out to you, that typically when you use that CA, the thin CA, it'll run down underneath and it'll puddle underneath the trailing edge, for example. The way to get that little puddle of glue off of there is to put your finger on the back side of it and press, and then when you press with the sanding block, put it right on there, and then let the rest of the wing guide the sanding block. So you can end up just sanding that little puddle off all by itself without really undercutting anything else. Okay, the puddle is gone. Now we'll have a nice smooth covering job. Okay, I'm just finishing up sanding off the bottom, and the wing is now flat from the leading to the trailing edge, and you can definitely see the twist in it that we wanted. It's built in. I don't know if you can see it on the camera. I'll try to line it up for you. Maybe you can see it. One thing I noticed when I finished sanding is that I didn't get a good fit on this one rib joint here. Well, there's two ways to try to accommodate that. One is to just fill up the gap with thick CA. Of course, that adds weight, as we've talked about before. So the other approach that I like to use is just cut a small sliver of 16th balsa and insert it in there, and then hit it with the thin CA, and you got a good solid tight fitting joint. Okay, got that little sliver, wedge-shaped sliver in there. Hit it with the CA. Hit it with the hardener, and then sand the piece that's sticking up off. Okay, there's a perfect joint. Now the last thing we've got to do is to shape the bottom of the trailing edge, or excuse me, the leading edge. And typically the way I do that is take about 3 strokes with the razor plane, and then round it off, and that'll be it. There's 1, 2, 3. That kind of puts a little bevel on it, and then you can just take the sanding block and round it right in. It gives you a reasonably sharp leading edge, which is what you want. Okay, I think that takes care of it. This wing is ready to cover on the right-hand side. So next, I'll show you how I line up this right half of the wing with the left-hand tip so that I can build the left main panel in between the two. Now we're ready to build the left main panel in between the tip and the right half of the wing. You'll notice that I've already positioned the left tip using the combination square and the prop, and a little bit of spray cement to hold it in place at the joint. And now to position the right half of the wing properly and get the dihedral in it that I want, I have made a little cardboard support fixture. Just made it out of a piece of corrugated cardboard. The dimension that I want to give me the right 10-degree angle at the center of the wing is 3.5 inches. But then I wanted to accommodate for the wing twist, so on the front part of the support I made it 3.5 plus the 3/16 that we used as the shim under the leading edge corner when we built that. Now I've also drawn a line on the workbench which is the continuation of the trailing edge of the left half of the wing, and I've positioned another combination square on that line so that I can back the leading edge of the right wing up against the square and rest it on this support, and then I will have the wing properly positioned and ready to start fitting the pieces in between. All right, I've now got the wing, the right half of the wing positioned properly. You'll note that I've added a few things. I've added another combination square at the leading edge to keep the wing from moving. I've added a weight at the leading edge near the center section joint to make sure that it stays down on the workboard. And I've also driven a pin in here. This is one of the few times that I ever use pins in the construction, and that is to just make sure that this thing can't move and that it stays down on the workboard properly. I've also added a pin here and another block there to make sure that the tip does not move fore and aft. And so now comes the the cutting and fitting of the spar pieces, the leading and trailing edge that goes in between the two halves to make it a complete wing. This gets a little bit tedious in that it's a sort of a cut and try process, but using a disc sander to grind precision joints, I can work up to it very quickly usually by just grinding off a little bit at a time and cutting and fitting. Now when I get close, the way I make sure that I don't cut too much is I take the edge of the pencil lead and make a mark right on the corner, and then I go over and I sand that mark off. That probably takes off maybe, probably less than a 64th of an inch at a time. So that way I can work up on the right fit, and then when it's right, it'll just slide right in with the proper angles cut on both pieces. As you can see, I've now got the trailing edge in there and the leading edge. The leading edge was a little whippy, so I've laid a straight edge along the front to make sure that the leading edge comes out absolutely straight. Now I'm ready to fit the lower spar in between. But I wanted to make a couple of more comments on getting these precision fits. I think as you're well aware from what I've said so far, I really believe that a disc sander is irreplaceable in getting the best possible fits that you can. And I mentioned the little technique about using the edge of the pencil. Another technique that I use is when I'm really close and I don't want to take off very much at all, I don't even turn on the power to the disc. I just use the miter gauge, put the part up against the disc, and then rotate it by hand just a quarter of a turn or so on. And that allows you to really make some fine cuts, still maintaining the precise angle and so on. So now I'll go ahead and fit the spars in, and this is the part that I really love, because we had a bunch of pieces and now you can almost start to see a complete wing growing right before your eyes. Well, here we are. We've got both spars added. The center section is sheeted behind the spar, and it's now time to put in the trailing edge gussets. I thought I might show you a quick way to make gussets that I've used for several years. Works out pretty well. Just take your steel scale and your piece of gusset material. In this case, I'm using 1/16 sheet. Cut off a strip of the gusset material the width of the steel scale, and then just use a combination square, the 45-degree angle part of it, and just slice it off. This is convenient because, if you recall, gussets need to have the grain running in the long dimension of the gusset for maximum strength. So you just keep turning the strip of wood over and cutting along the straight edge on the combination square, and you whip out the gussets. So that takes care of that. At this point, I've added the vertical grain webbing between the top and bottom main spar, and I wanted to point out that I have carried that webbing all the way into the center, even though I have a 16th plywood dihedral brace here. The significance of that is that what that does, the dihedral brace in combination with the vertical webbing makes the spar into what's called a box spar. And the box spar combined with the center section sheeting makes the center of the wing incredibly strong, but at a very light weight. When we're talking about weight, it might be appropriate at this point to talk about what the weight goal for this wing was. I generally establish some goal based on experience usually as to what I think a component is going to weigh. The goal for this wing was 100 grams. That's a 473 square inch wing weighing 100 grams, totally covered, ready to fly. Fortunately, I think we're going to be very close to that on this wing. I weighed the completed right panel of the wing. It weighed 38 grams. Assuming that the left half of the wing will come out weighing that same amount or within a gram or two, that gives us 76 for the bare structural weight. And then I've calculated that covering the wing with mica film will add an additional 22 grams. So as you can see, we're getting right up there, right close to the 100 gram target weight. And if I can achieve that, I think that'll be very good. This will be a very strong wing, but yet very light. About 100 grams is roughly 3.5 ounces. Now let's review the weight of the woods, because that's all important in achieving any overall weight. The wood that I used is 5-pound stock for the trailing edge, the leading edge, and the ribs. It's all C grain. I recognize that C grain may not be, the grain may not be visible, but and if you're not familiar with what the different grains look like, if you ever see a sheet of balsa wood that has a speckly appearance on the surface, that's C grain, and that is the stiffest of the cuts. The other two cuts are A and B, obviously, and they have different purposes. A is a good spar material, although the way the log is cut, when you cut a piece of C grain vertically, you end up with A grain. So I use typically C grain even for the spars. Now the spars are heavier material. They are made out of balsa wood. I'm sorry I didn't weigh this particular piece of balsa wood, but it's heavier, probably in the 8 to 9 pound category, and it's typical of the wood that you can buy in the hobby shops, and in fact that's where I got the wood that I stripped these spars out of. The sheeting for the center panel is the absolute lightest that you have. In this case I used 4 3/4 pound stock, again C grain, but that'll be quite strong enough. I don't know if I mentioned it, but the spar webbing is 7 1/4 pound stock. A little bit harder, a little bit stronger, because we want it to control those spars and keep them from moving under stress. So now I'll go ahead and put in the diagonal spars the diagonal ribs and the leading edge turbulator spars, and the wing will be finished. Here's the wing, structurally complete. There's only 4 more things that we need to do before it's ready to cover. And those four things are put the plywood dihedral braces at the tip dihedral joint, put a piece of 1/32 plywood at the trailing edge of the wing to reinforce the trailing edge against the rubber bands that hold the wing on the airplane. We need to balance the wing, and the way I do that is I just put my fingers at the center joint and see if it tips one direction. And you can see that this wing is slightly down, meaning that I need to add a little bit of weight out at that tip. When I have to add weight, I use the smallest piece of lead that I can and get it as far out to the tip as I can, and glue it on with thick CA. And the fourth thing that we have to do yet is to provide some means of structurally stabilizing these diagonal ribs. The purpose of the diagonal ribs is to add torsional stiffness to the wing. Now, if you zoom in and take a look at this rib right here, you may be able to see it. No, actually, this rib here is showing it a little bit better. You can see that rib is twisting and bowing as I twist the wing. Now, the way that can be accommodated is using thicker wood, but since we're looking for the absolute minimum weight that we can achieve, I chose to use 16th wood with the idea of providing some means of stabilizing that rib or securing it so that it cannot either twist or bend. And the way I do that is using Kevlar thread. Kevlar does not stretch, but is a very fine, can be bought in a very fine thread. And so what I do is I take a needle and just below the surface of where the covering will lie, I poke a hole with the needle in each of the ribs all the way out, and I'll stop at this point. The way I'll do it is I'll poke the holes in all the ribs, glue the Kevlar thread into this rib, then thread it through all of the holes, and then pull it tight at this point, and while I'm holding a little bit of a tension on it, glue it at all of the other ribs. I'll do the same thing on the bottom of the wing. So what I end up with is two threads, one at the top of the airfoil, one at the bottom of the airfoil, halfway between the spar and the front of the trailing edge. That will provide incredibly increased stiffness to the wing with essentially no additional weight. So with that, let me show you how I go about putting the plywood gussets in at the dihedral joints. I use 1/64 plywood here, and since this rib is continuous, I have to saw a kerf in there, and so I use an X-Acto razor saw, the one with the coarser teeth, which happens to cut a nice 1/64 kerf, and then I just saw down behind the spars until I'm through, all the way through the rib. Then once I get it cut off, this rib is flexible, and you can bend it out of the way a little bit and smooth off the back side of the spars. And then I just slip a piece of 1/64 plywood in there, mark it, cut it with scissors, by the way. I don't know if you're aware, but you can cut 1/64 and 1/32 ply with a pair of scissors, and that's the way I do it. So I'll draw the pattern right from the spars, cut it out, slip it in, and glue it. Then when it comes time to re-glue the rib to the back of the gusset, I'll be sure that I want to put that down on the workbench so that I don't build in any twists and I get everything all lined up properly. So I'll go ahead and do all of that, and then we'll be ready to talk about covering. Now I have the Kevlar thread put in one half of the wing, and I think you can see, if you look, if you can zoom in on this, you can see that when I twist it, the wing, these ribs don't move now, and consequently the wing is considerably stiffer than it was before. Now, in addition, when we put the covering on, we'll make sure that the covering adheres well to these diagonal ribs also, and that will add additional stiffness. Thinking about twisting wings, though, or any structure on an aircraft, that's a good thing to do to see if you've broken any joints or anything, you know, such as when you've been sanding it or something, you might have broken a rib loose or something like that. If you twist the wing and listen to it, you can hear a creak or a crack or a scraping sound any place there's a loose joint. And if you can then go immediately to that joint and fix it. That's not only useful while you're building the airplane, but it's also very useful after it's completed and flying. You know, if it has a hard landing or something, you can check very quickly and very easily to see if there's any structural damage or any broken joints. Now, one other thing that I wanted to mention that occurred to me while I was threading this Kevlar in here, and that is you can take the Kevlar thread, the piece that you're going to use to try and thread it through, and put a little the thin CA right on the tip of it, and then spray it with the hardener. And what you end up with is a built-in needle, and then you can cut that piece off when you're done. Now that the wing is structurally complete, it's time to prepare the wing for covering. And before I get into the preparation, I might just talk a little bit about the covering material that I've selected. On all my models, I use Vulcerite microfilm. Microfilm fits into the category of the heat shrink plastic type fittings, coverings rather. But the one advantage that it has is that it is much lighter than other products available, and it's also very tough and puncture resistant, both of which are good characteristics for free flight models, where the model might be coming down in wheat stubble or corn or what have you. The one disadvantage that Vulcerite has is that I don't believe that it provides quite the structural stiffness through the stressed skin concept that some of the other coverings might. And consequently, you need to put most of the stiffness into the structure, and we've talked to a great deal about how that's done using the Kevlar thread and the diagonal braces and so on. That's not to say that the Vulcerite does not add significant stiffness, and in fact, it will add. But as I think I mentioned before, we need to make sure that it adheres to these diagonal ribs in order to take best advantage of that. So to get on with the preparation then, at this point I use a material called lightweight spackling compound. Super lightweight, this one is called. And it's available in most any hardware or paint wallpaper type store. And I use it to fill in any voids that I might have left, such as there's a little spot right here that's the end of the dihedral brace that didn't quite come up flush with the surface. And then there's a little dip in the spar right there, and I'll fill that in. This stuff sands very nicely, sands much like balsa wood. And I just use my 6-inch scale to put it around. The other places I use it are in the rib notches in the trailing edge, where if the rib doesn't quite fill up the notch. At the joints And that brings up a point that I'd like to zoom in on here and show you one very critical joint that must be filled in. And I think that should probably zoom it in. And that is this joint right here. This is critical because if there are any gaps at this spar, when you cover it and then shrink it, you're going to get wrinkles that go like that. So to make sure that it's smooth across that spar, I'll put a little of this Spackling Compound in there. And that way I'm assured that I'll have a nice continuous surface across there as I put the covering on. The way I cover is that I cover the center panels first on the bottom, then the tip panels on the bottom, and then everything on the top. I guess one thing that I'd like to comment about balsa wood and nicks and dents and that sort of thing at this point is that every time you get a nick or a dent in balsa wood, as long as material hasn't been removed, in other words, as long as a chunk hasn't been broken out, you can most likely restore it to its original contour by using water. I put water directly on the wood, or if the wood's already covered and I get a dent in it, you can use a syringe to inject water into the wood, and then you take the sealing iron that we're going to attach the covering with and put that on there and boil the water out, and it creates steam, of course, and you end up then with the balsa wood coming right back out. If there's a break there at that point, then you can hit it with a little of the thin hot stuff, and it'll go right into the crack, and you'll end up with probably stronger structure than you had originally. So I'll go ahead and finish up with the filling, and then I'll come back and we'll talk a little bit about the use of the Vulcerite adhesive. Now all the filler has been dried, let to dry, and sanded off smooth, and we're ready for one last step of preparation before we put the Vulcerite on. And that preparation is sort of seasonal, if you will. I've observed that whenever I built a wing in the summertime when the humidity was high and covered it, then in the winter when the wood dried out, I got a bunch of wrinkled blisters, if you will, that ran along span-wise along on the trailing edge and on the sheeted material. So I thought about that for a while, and I concluded that what's happening is that the wood had absorbed the moisture from the high humidity that's present in the summertime, and then in the wintertime it dried out and shrunk down, and of course the covering didn't shrink, and consequently it pulled loose from the adhesive, and you ended up with the blisters. I happen to be covering this wing in the wintertime when the humidity is quite low, so it's not going to be a problem now. But if you ever want to do any covering in the summertime, the trick that I've found that seems to work pretty well is to take the sealing iron and before you put the Vulcerite on, run the sealing iron over the wood and heat the wood and drive the moisture out of it. Now, I haven't tried it, but I assume you could use a heat gun to do the same thing. But by heating the wood and driving the moisture out of it, then going ahead and putting on the Vulcerite, you tend to eliminate or minimize at least that blistering. Now the blistering is really not that much of a problem because in the summertime when the when the moisture content in the air comes up, the wood swells back out and the covering is smooth again. So it's just one of those things that you'd like to avoid if possible, but it's not really that big a deal. So now let's talk about Vulcerite. I use Vulcerite right out of the can. I don't thin it at all, except when it starts to thicken, just from the can being open after I've used up about a half of the can. I then put a little thinner in it to try and get it back to the original consistency that it had when it was new. And I'm not sure what they use for thinning. I use Aerogloss dope thinner, and it seems to work quite well. I don't see on the can anything else that they recommend for thinning. But I just brush it on right out of the can. I guess one thing that I might mention is that you need to keep the brush clean, and by that I mean clean the brush periodically while you're putting the Vulcerite on, because what happens is that the Vulcerite tends to collect on the brush, and then sometime on a long stroke you're going to get a glob of semi-dry Vulcerite laying there, and then when you iron over it, it's going to turn into like a spot of jelly underneath the covering. So you want to try and avoid that to get the nicest possible covering job. I just use one coat, with the exception of where I want to be sure that the Coverite adheres to the wood for structural purposes. And in that case, we're talking about these diagonal ribs, so I'll be putting two coats on the diagonal ribs and the straight ribs in the back part of the wing here, on the top and the bottom, and on the dihedral joint ribs where I want to be sure that the covering sticks and doesn't pull away. So with that, I'll go ahead and put the Vulcerite on the wing, and we'll be ready to start covering. I guess there's one last comment I'd like to make about Vulcerite, and that is that I like to use it because it does indeed harden the surface of the wood and helps prevent nicks and dents and so on.
The first thing that you have to do is to lay out the panels that you're going to be using to cover the actual wing in this case. And you try to do this as efficiently as possible. I use an alcohol pen that's one of the non-permanent types to actually mark out the patterns on the covering material so that I can then cut them with an X-Acto knife or a razor blade. Some of the manufacturers recommend leaving a border of about an inch around the actual panel that you're covering, and I found that that tends to be a little bit more than you really need. And it's important to plan properly so that you minimize the amount of covering material needed for a particular project.
Now I've cut out all the panels that I'll use to cover the various sections of the wing. I guess one thing that's important to keep in mind when you're cutting the panels is that the grain of the material should always run span-wise. The grain of mica film always runs the length of the roll. And with this transparent mica film, you can actually, I don't know if the camera can pick it up, but you can very easily just look at it and see that the grain is running in the long direction. So now we're ready to start the actual covering process. As I mentioned, I cover the bottom first. And when I'm covering, I try to work in triangles. And by that I mean I tack it down in the center, for example, and on the spar out at the dihedral break, and then I pull it snug, not tight, but just snug and smooth, and tack it down there. And that gives me this triangle that I'm working on. Then I can pull it smooth out here and tack it down at this point. Then I do the same thing with the leading edge. Tack it in the corner, smooth it out, and tack it in the other corner. Now you notice that I haven't done anything with the material that's going to go over the center section sheeting. And that's because I always work from the inside out, starting with the open bay. So what I'll end up doing is sealing the material down all around the open bay, then actually shrinking that except for this last panel. And when I get to that, I'll mention that. And then I'll come back and iron the material down over the wood. Now the reason I do that is so that if I do get a wrinkle, I can pick up the narrow tack line where I've tacked it down and stretch it out and then reseal it. So that way I'm assured of getting a wrinkle-free covering job. Now one other thing that I wanted to mention is that you don't just iron the joint down. You have to tack it every 1/2 to 3/4 of an inch or thereabouts by just touching the iron to the material. The reason for this is that if you try to run the iron down, the material will flow ahead of it, and then all of a sudden when you get out to the corner, you'll have a big wave in the material. Whereas if you tack it down and then go back over it a few times, then pretty soon you can indeed then just rub it down, and it will be tacked in a narrow line. I'll do the same thing along the trailing edge. And you notice I'm rubbing it both ways. I'm going this way a little while and I'm going that way a little while. That again is to keep the material from bunching up ahead of the iron. And do a little more tacking. You notice that I'm just tacking down maybe an 1/8 of an inch wide strip at the front edge of the trailing edge. And that's so, as I said, that if I do get a wrinkle someplace, I can heat it with the iron, lift it up, and pull the wrinkle out. Now, when we come to the polyhedral rib, the rib that is where the main panel and the rib join together, and the root tip, the tip rather, join together, I do a little something extra there. I iron it down, of course, to the rib, but then when I trim it off, I leave a 1/16 or to an 1/8 of an inch, and then I fold that over and iron it to the face of the rib. That assures me that while shrinking and so on, that the covering will never pull loose from that rib. But right now I'm just going around and sealing it down around the periphery. Turn it around here so I can work on it more conveniently. Now we haven't done anything to the leading edge yet, so we need to start with the spot tacking. And then go back and spot tack it a few more places. And when you'll notice that I'm just pulling it smooth. I'm not putting much tension, if any, on it, but just pulling it out to the point where it's lying on the surface smoothly. And that's the real secret with microfilm, I think, is you can't expect it to shrink up as much as other covering materials do. So you need to start off with a pretty smooth covering job on its own. And that is the basis for this idea that I've come up with about not finishing off the edges until I'm sure that the center panel or the open bay is going to be okay. And just touch it down, and then okay. Well, it looks like I have it tacked down and ironed down all the way around. So now we'll just take the iron and shrink it up tight. Notice I haven't done anything with the ribs yet. Once I get it shrunk, then I will go back over and iron it down and make sure that the material adheres to the ribs, because if you recall, that was something that we needed to do to add to the structural stiffness. So we're going to do some shrinking. I usually start at either edge and work it a little bit toward the middle. And I use the light to see how the shrinking is going, but I am very careful not to get the iron over the place where I have sealed it down, because if I do that, the iron will soften the adhesive, and the shrinking of the material will then pull it loose, and you'll end up with a wadded up mass. And that, by the way, is why they tell you, if you read the microfilm instructions that come with the material, to not try to use a heat gun. First of all, you don't need a heat gun because the iron shrinks it up very nicely. But the heat gun, of course, puts heat all over the panel, and it's consequently going to soften the adhesive around the edges at the same time it's shrinking it, and like I say, you're going to get a wadded up mess. Now the reason that I shrink it back in this area, but I don't shrink this last bay, is because if I shrink this last bay before I get the covering on the other side of that rib, it's going to end up bowing the rib, and that of course will give me wrinkles. So I want to wait until I've got something holding it from the other direction before I shrink this last bay. Okay, we're coming up to the last bay. I'm shrinking the second to last bay now, and it's looking good. Might just comment on heat. The iron temperature is a little less than 250, probably maybe 225 or so. And that's good for, that's plenty of heat for the adhering of the material to the structure, and also for shrinking it. Now, if you should happen to get into a little bit of trouble with a wrinkle, you can increase the heat and apply it to the general area where the trouble is, and that will shrink it more. The higher the heat, the more it shrinks. Okay. The panel is applied and it's shrunk down all around, so now we got to take care of the material that is covering the sheeted section. The way I do that is I start generally in the middle of the area, and with the tip of the iron and circular motions, I work my way out to the edge. And this again is to keep the material from bunching up and causing a wrinkle. So I'm putting a little bit of tension on it, not much tension, but just enough to keep it smooth, and I'm working my way from the open area toward, in this case, the center of the wing. The idea is that you always want to be working toward the open edge so that, well, for one thing, you don't trap any air under it, and secondly, you can work with it, and if it starts to bunch up on you or something, you can heat it and pull it to stretch it out a little bit and stretch it and shrink it as necessary in order to get it to lay smoothly on the wood. Circular motions. If you do get a little bubble, you can just take the iron away and then rub it down with your thumb, and that'll usually cause it to adhere adequately. One thing that I should mention is if you get too much Vulcerite on there, that will generate bubbles. So that's why I use only one coat, except where I need to make absolutely sure that I get a good adhesion of the material to the structure, such as on the ribs, as we talked about before. So we're coming up to the center joint. I've made it all the way to the center joint on this spar here, and no bubbles so far. Yep, there's a little bit of bubble. Now that bubble was caused by a little bit of a thick place in the Vulcerite. Okay. Work down. Now we want to, again, I'm still trying to work in triangles, and I'm working now with a triangle that's working toward this corner back here. Trying to make sure that I don't trap any air underneath of it. Okay, down to the trailing edge now. Working out to the trailing edge. Again, as I work down the length of the trailing edge, I'm just putting a little bit of tension on it in the loose area here, and then ironing it down, working from the open bay area toward the edge. Going down nicely. This new transparent microfilm really works much easier than the old material. Although I enjoyed the old material, or what I call the old microfilm, because it looked much more like doped tissue than the new. And so for aesthetic reasons, I always enjoyed the older, but it's not available anymore, so you use what there is. Okay, a couple of little bubbles there, work them out with my thumb, and the trailing edge is sealed down. Now, I generally don't do this till a little bit later, but I'll show you while we're here. In order to prepare for folding the material over the trailing edge, I pull it over at about a 45-degree angle and then iron right down the corner. And what that does is it makes sure that I got good adhesion right at that critical corner. Otherwise, when you folded it over and ironed it on the trailing edge, you might end up with a little bit of a bubble right at the trailing edge where it has kind of lifted up. But what this does, it sort of pre-bends the stuff and gets it going in the right direction. Now we'll turn it around. We'll do the same thing with the leading edge all the way out to where the tip panel joins on. Again, pulling it and rolling it around the curve slightly of the leading edge, putting a little tension on it, and running the iron around the curve and laying it down. All right. So now we're ready to trim it off at the ends. I'll trim it with the little surplus here, as I mentioned, and then wrap it over and iron it to the side of the rib. And then I'll come back and show you how I trim the edges so that I get a nice straight seam. I've trimmed off the ends of the panel that we covered, but I wanted to zoom in here so that I could show you the little tool that I use, if you will, to trim the edges. Basically, it's nothing but a piece of balsa wood, in this case 1/8 inch, and a razor blade wherein the point it's been broken off such that there's a sharp point on it. Then I just insert the razor blade through the balsa block at some convenient distance from the edge, and that makes a trimming tool. The distance from the edge, of course, determines how much material is going to be left on to fold over, and so I'll go ahead and trim these, and you can see it in operation, but I'm going to have to shut this off and then reset the camera so you can see that. Okay, we got the camera repositioned, I think, so that you can now see how I use this. And basically, I put with the big part of the razor blade up, I put the balsa wood underneath the microfilm that I want to trim off, and then I start sliding it down. Well, if it doesn't want to get started, you can just push down on the razor blade a little bit, and it'll act like a pair of scissors, and it'll get you started, and then you can just zip it right off. It gives you a nice, clean, straight cut on the trailing edge in this case. Now I do that to both the leading and the trailing edge, and then we'll be ready to put the tip on. Actually, I'll go ahead and cover the tip. I guess the only thing to note is that right here I'll paint on 2 coats of Vulcerite so that I'm very certain that the tip material will adhere at this joint. because the only thing that ties it down is the width of the, the width of the glue bead that you put right here. So I'll be back when I've got the tip nearly covered. I'm going to want to show you a little bit of technique on how to get around the compound curve at the tip.